Okay, so this is graphing sine, cosine, and tangent functions, and for whatever reason I didn't put your learning target. Learning target, I can graph trig functions. Alright, so this is what we're going to do, and we're going to learn how to do this. You can do these on your Desmos calculator. You can also do them on your TI-84 calculator, or you can always graph them by hand. That's not the most fun thing to do, but it is an option. Okay, so the first thing we're going to look at is we're going to look at just the sine and the cosine functions. So if you look at those graphs, they're the exact same graphs, just a little shifted. So look at where they hit the y-axis. The sine graph is always going to hit at 0, 0, and the cosine graph is always going to hit at 0, 1, unless a transformation has happened, and we'll talk about that in just a little bit. Okay, so the sine function usually is going to look like this. F of x equals sine of x, and the cosine function is going to look like cosine of x, unless a transformation happens. Alright, so here's some stuff we're going to talk about. We're going to talk about two things, the amplitude and the period. So I just want to draw them first. This distance right here that I just drew is going to be called your amplitude. Or if you look over here, it would be like this distance. And then we're also going to talk about something called a period. So if you look from here to here, that's called your period. So the time it takes to make a complete revolution. If you look at this one, from here to here would be your period. Alright, so I'm going to give you some actual definitions of the period and amplitude, but I wanted you to see it as a picture first. So notice that the cosine function is a horizontal translation of the sine function. So if you take the sine function and you just move it over, that's how you get your cosine function. Any transformation of a sine function is called a sinusoid. I hate saying that word, sinusoid. I have to stop and think about it. If we're from the country and you want to call it a sinusoid, that's fine. It's called a sinusoid. Okay, moving on. Alright, let's look at the period and the amplitude. Alright, so here's the definition for period. I'm just running out of room, so I'm going to put it down here. The length of a cycle. So this is why women have periods, because it's the length of their menstruation cycle. Alright. It could start at any point on the graph. Just like a period can start any day of the month. I'm sorry, but this is where it comes from. It's gross. Okay, so I'm going to erase this, and I'm going to write the definition for amplitude. Alright, so the amplitude is half the distance. I'm burping Dr. Pepper. I'm sorry, that's gross. Half the distance between the minimum and maximum values. So once you get those definitions written down, I want you to go back and I want you to look at that picture and see if you can understand the picture and the definition in words and how they relate to each other. Okay? So now I'm going to show you where you find these, because they're just little formulas. So if you look right here, this is kind of how we break down the sine and the cosine function. So when I'm talking about the letter A, I'm going to circle that in green. That's just a number in front of the word sine or in front of the word cosine. And whenever I talk about B, I'm talking about the number in front of X, but after the word sine or cosine. Okay. So the amplitude is found by doing the absolute value of A. So whatever number is in front of sine or cosine, you're always going to make it positive, and that's going to be the measure of your amplitude. B is a little different. It's got a formula. So B is, the period. The period is found by doing 2 pi divided by the absolute value of B. So 2 pi divided by the number you find in front of x. And it's always going to be positive. So a period is always going to be positive, and an amplitude is always going to be positive. Okay, and we'll do some problems like that in just a minute. Alright, so now we're going to look at the tangent function. So this one is so different from the cosine and the sine function. These have these weird things, asymptotes, which we talked about in our rationals unit. So they're just those imaginary lines that the graph gets close to, but it doesn't ever touch. So the tangent is the craziest looking graphs that you'll ever find. The tangent function is undefined for certain values of x, therefore the tangent function has vertical asymptotes. The tangent function does not have an amplitude. So you'll never be asked to find the amplitude of a tangent. Or if you are asked, then the answer is no solution or something. So if you look at this, so tangent usually looks like f of x equals a, which is just a number, tan, b, just a number x. The period for this one is found by doing pi divided by the absolute value of b. So it's no longer 2 pi, it's only just 1 pi. And the asymptotes are always odd, and they're going to be multiples of pi divided by 2, absolute value of b. Okay, so that's just some weird formula stuff to get used to. Okay, so we're going to look at these 3 different functions, and we're going to identify the amplitude and the period of each of them. And you can always graph these, and you can look at them and see if they make sense to you. But we're just going to find the amplitude and period, and then we're kind of going to move on, because I'm pretty sure you can type things in Desmos and get a graph, or you can type things in your calculator and hit graph. Alright, so if we look at the first one, we got sine of 4x. So notice that there's an understood 1 in front of sine. Alright, and then there's a 4 in front of x. So that 1 is your a, and 4 is your b. Okay, so when we want to find amplitude, it's just the number in front of the word sine or cosine, and it makes sure it's positive. So the amplitude is 1. Pretty easy. The period, if we want to find, it's going to be 2 pi divided by the number in front of x, and just make sure that everything's positive. So the number in front of x is 4, and if I want to reduce 2 divided by 4, that's just 1/2. So it's going to be pi over 2. That's pretty easy. Okay, so if you look at the next one, f of x equals 7/2 cosine of x. The number in front of either sine or cosine is a. There's an understood 1 in front of that x, so that's my b value. So my amplitude is just 7/2. Remember that it's just always positive, and it's the very first number. The period is found by doing 2 pi divided by that number in front of x, which is 1, and 2 pi divided by 1 is 2 pi. So these are really simple, as long as you know the formulas. So if I look at the next one, f of x equals -5 cosine 1/3. That's my a value. And this is my b value. So my amplitude, remember it's always going to be positive, so it's just going to be +5. Period's going to be just a little bit weird. You just have to know some random stuff about how numbers work together. So remember 2 pi divided by 1/3. Okay, so that looks really weird. We're never going to leave that like that. So think about this as being 2 pi divided by 1/3. And remember, anytime you're divided by a fraction, you do same, change, flip. Same, change it to multiplication, flip the last fraction. So if I do 2 pi times 3, I get 6 pi. That's how your answer is going to look on a test or a quiz or a multiple choice on the EOC. Okay, so pretty easy. Just have to know the formulas and figure out where you're going from. Alright, so now let's look at the tangent. The tangent is the craziest graph of all of them. It has these weird vertical asymptotes that we've talked about during your rationals unit back in Math 3. You probably blocked that out. It's not a pleasant experience. So remember, vertical asymptotes are those imaginary lines that a graph gets close to, but it never actually touches. And then a period would be like from one little graph-looking thing to the other. And then you actually don't even have an amplitude for these. Okay, so if we look at the words, the tangent function is undefined for certain values of x, therefore the tangent function has vertical asymptotes, which is what I did in those little blue lines, they look like rain. The tangent does not have an amplitude, so anytime if it asks you to find an amplitude, it's going to be no answer, because you don't have one. The tangent function looks like this, very similar to those a's and b's that we talked about in sine and cosine. The only difference is when you talk about the period this time, it's going to be pi divided by the absolute value of b. So it's not 2 pi divided by b, it's just pi. And we're actually not even going to look at this because that's just more pre-cal stuff and I don't want to confuse you, so it ends right here. That's a period now. Okay. Alright, so we're going to graph these functions, and you can graph them in Desmos really quick, or you can use your graphing calculator. So this should say 4 tan x, and then this one over here, well, if it'll let me write, negative tan 1/2 x. So first thing I want you to do is I want you to graph these in Desmos, or you can graph them in a TI-84 calculator and sketch you a little graph. So try that in 1, 2, 3. Okay, this is not accurate. This is just a little sketch. Sorry, I'm just getting lazy in my old age. But this is what we're doing. The graphs look crazy because of those vertical asymptotes. So now let's just find the period. Remember that the period is going to be pi divided by b. B is the number in front of x. So notice in that first one, you don't have a number, so it's understood 1. And pi divided by 1 is just pi. So the period of that first function is pi. The second one, the formula is pi divided by the number in front of x, which is 1/2. So once again, we have that 1/2, pi divided by 1/2. So you do same, change, flip. So your answer is actually 2 pi. Okay, so that's kind of weird. But I want you to see what an EOC problem would look like. So function f of x equals a sine b of x plus h. That looks exactly like the problems we just did, except it's got that plus h on the bottom. Alright, it has a period of 6, meaning that when I do 2 pi divided by b, I get 6. It has a minimum value of 2. When I do x is equal to 2.5, then y should always equal 5. Alright, and now I'm just trying to figure out what are the numbers a, b, and h. So I'm going to use this part first. So I'm going to work backwards to figure out what my number for b has to be. So the only thing I can do to get rid of dividing by b is multiply both sides by b. And then if I wanted to get b by itself, I would have to divide by 6. So 2 pi divided by 6 is pi over 3. So now I know that b equals pi over 3. And then I'm going to be completely honest, trying to find a and h are pretty difficult, and I can't believe that North Carolina would put this on the EOC. But we're going to do it. I'm going to erase the blue part for right now, just so I have extra room. Okay, so what I'm going to do is I'm going to draw a little graph. Okay, so like this. And then we're going to think about the idea of minimum value. Okay, so what I've drawn is the period. Okay, so it started at 0, it crossed the x-axis, and it came back up. That's how I know it's an entire period. I also know that the period is 6, So think about like this being a halfway point, this being like a fourth of the way, and this being 3/4 of the way. Okay. Alright. So I know that 3/4 of 6 is 4.5. Okay? And then I know the equation looks like this. So I'm going to plug in 4.5 times pi over 3, because I know that's my period, plus h, and I know that the minimum value equals 2. Okay, and I picked that point because if you'll notice, that's your minimum point. So now I'm going to use the part in yellow, that f of x equals 5. So what I'm going to do this. So I'm going to use the fact that if I plug in 2.5 for x, I should be equal to 5. So just to make it a little easier, the part in yellow, I'm actually going to plug into my calculator and get a value for. So that's what I've done here. I've highlighted the part in yellow that I'm going to plug into my calculator. Okay, so here's what I got. When I did the first one, I got -1, and when I did the second one, I got 1/2. And now I'm just going to clean it up a little bit. So like I would never do an a times a -1, I would just write -a. So I'm going to clean it up a little bit. Okay, and this is why this problem is so difficult. Because what you actually have is a systems of equations. Oh, there's a plus sign there, equals 5. And that's from actually math 1. And so what I'm going to do is I'm going to try to solve this. So I'm going to solve the first one for h. So if I add a to the other side, I get 2 plus a. And now I'm going to take this equation and I'm going to plug it in right here. So if you need to watch a video on solving systems of equations, you can. So I'm going to replace that with 2 plus a equals 5. So now I'm going to simplify everything. So I get 3/2 a plus 2 equals 5. So I'm going to subtract the 2 to the other side, and then I'm going to divide both sides by 3/2. And I get 2. So now I know I did all that work just to find that a equals 2. But I could use this one right here. If I know a equals 2, then h equals 2 plus 2. So h equals 4. Oh, so that's a lot, I know. But now I have all my values. A is 2, h is 4. So a is 2, h is 4, and b was found by doing pi over 3. That is a yuck problem, but that's what they put on the EOC. So try your assignment. I know this is very difficult, and you're really tired, and we're almost done with the semester. You've done a great job. Keep pushing through. Let me know if you have any questions. I'm sure you do. I will help you as much as I can. I'm sorry. Okay, bye.